So we're going to start with we've been given to simplify. Let's set A intersection A complement intersection B, A intersection A complement intersection B complement, and then another complement. The question is simplify in the simplest form. So how can we go about it? So all the laws that I wrote down, these are the ones we're going to use to be able to work out this one. So we are going to get first this complement which is outside. I'm going to distribute it. Now in this case, this will be considered as one part, this will be considered as one part separated by an intersection. So if I distribute this complement, we are going to have a complement. The sign here, remember, according to De Morgan's law, is going to change into union. And then we are going to have a complement intersection B. We have got a complement here, and then another complement will come here since we've distributed this complement. So this will give us a complement union a complement intersection B, since two complements cancel each other. And then we are going to use now distributive law. I'm going to get the A complement union, so that will be A complement union first with this one union A complement, and then we get a sign which is on the middle here, and then the same A complement union, and then that side. Remember what we said A complement union A complement is? Whenever you get the same thing, you perform a union, it will be that same thing, so that will just be A complement. And then you have got so this part has given us A complement, and then you've got intersection A complement union B. Now you might not see exactly the answer here, but what you can do is you can just use shading to leave it in the simplest form. If you have got A here and B here, so first we are talking about A complement, which is here. So this is A complement, and then now let's shade A complement union B. So A complement is what I've already shaded. Now union means together with B, so I'm also going to shade B. Okay, so this thing I've shaded in yellow is A complement, and then together with B or union B, that's the one. Now yellow plus what? Okay, A complement union B, I'm going to put it like that. That's the one in blue. And then we have got also A complement which is just in yellow. Now from what you can see, where are they meeting? Where is A complement? Where are the blue lines meeting with the yellow lines? So you can see it is just in what? In A complement union B. Okay. Really not even A complement union B. Look at this clearly. The middle here, we don't have any yellow line. And we are talking about the intersection of A complement and A complement union B. So basically, if you intersect A complement and complement intersection B, you are just going to get A complement. That's the answer. That is because if you see the yellow lines and the blue lines, they are just meeting outside A. Like in A, we don't have any yellow line here. So we've simplified it to the simplest form. That is how you get to simplify. Maybe someone is left behind. Anyone left behind? Yes. Pardon? Can you just repeat? Yes. Which one? This one? Here? Okay, so what we are saying is if you get A union A, this will be A. If you get A complement union A complement, it will give you A complement. The same thing if you get it, you perform a union, it will give you that same thing. That's the A complement. Or maybe it's on another stage. You are okay? Are you okay? Okay. So let's look at another one, simplifying. So this one is simplify x complement intersection x complement intersection y complement and then another complement. So how do we work this one out? So there are many ways you can work out. What I'm going to do is I'm going to start with the complement that is outside and distribute it with what is inside. In this case, we're going to take this as one part, this also as one part. So that will become x complement. There will be another complement that comes, and then the sign here changes into union. Then we're going to have x complement intersection y. We have got this complement plus the complement that comes, there will be 2. So this will be just x union x complement intersection y. The two complements cancel each other, the two complements cancel each other. And then from here we can distribute x union with x complement. So that will be x union x complement. And then we'll get a sign on the middle there. And then we distribute again the x union with y. So that will be x union y. Now we already said x union x complement. If you combine x with what is outside x, you are going to get the universal set. And then intersection x union y. And we said any point where the universal set intersects with a set is that same set. So this will give us x union y. This is the simplest form. Any question? Yes. Uh-huh. So every time you distribute a complement, according to De Morgan's law, when you've got A union B complement, when you distribute this complement to A and B, the sign on the middle changes. If it was intersection, becomes union. If it was union, becomes intersection. Does that answer the question? All right. Okay. So let's look at another one. Now this one is telling us to shade. By the way, these are exam questions we are using. So this one is saying shade the set described by B union A complement intersection C complement then another complement outside. So as you can see, the way it is, it will be very cumbersome to be able to shade. So we need first to simplify. So I'm first going to distribute this complement. So it becomes B complement. This sign here is going to change into intersection. Then we're going to have A complement, intersection C complement, and then the complement also will go on this part. And then this will give us B complement intersection. Again, I'm going to distribute this complement to this and this. So it will be A complement complement, the sign changes into union, and then to be C complement complement. So this will just give us B complement intersection A union C, because two complements cancel themselves. Then we can shade. Remember, we've got three sets here: set A, set B, and then C. Yes, go on. Okay, so what we are doing is we'll get this complement. We are going to distribute to this and this. These are in brackets, so we're going to consider it as one part. So if we take it, the complement to B, it becomes B complement, and immediately the sign is going to change into intersection. And then we've also distributed this complement to this other part, so the whole of this part will take it as one. So it becomes A complement intersection C complement, and then there'll be a complement that comes from the distributing. Then from there, now we can distribute this complement to what is inside. So that will give us B complement intersection A complement complement, because we already have a complement plus this one, there will be two. And then the sign changes into union, and then we're going to have C complement and then another complement. So that is what gave us A union C, because two complements cancel themselves. Is that okay? Alright. So now let's shade. The first thing we should shade is B complement. Let's first shade A union C. So A union C is everything in A and everything in C. But we want where A union C is intersecting or meeting with what is outside B. Shouldn't shade anything in B, but it should be in A union C, but not in B. So this would be the answer. Partial union, but not anything that is in B. So it should be B complement, but intersection A union C. That is it. Can we go to another one? Is that clear? Okay. So this to shade. This one was saying shade B union C minus A intersection B. Okay, so let's shade this. B union C minus A intersection B. How do we shade it? If we want to first simplify it, or we can just write like that, but let's simplify it. Remember, when you've got x minus y, this is the same as x intersection y complement. So the second thing to be mentioned, we just put an intersection and then we put a complement. So that's the same with here. So this is B union C, and then intersection. The second thing, which is the A intersection B, we'll put a complement there. I think this would be enough for us to shade. We have got the set A, the set B, and the set C. So the first thing we are talking about is intersection B. Where is A intersection B? It is this region. But we are interested in component, not in A intersection B. But what is outside A intersection B? So that's the one we are going to shed. What is outside A intersection B is this region. And then that outside A should intersect with B union C. In other words, it should be in B union C, not just anything else, but it should be in B union C. So we'll just go in B and C. So we'll shade B union C, but we are not going to include what is in the intersection. That is it. I've shaded everything in B and C, that's the meaning of union, but don't include A intersection B. Is that okay? Okay. So for this set, we are shading the B union C, just everything in B together with everything in C. But it shouldn't include the intersection of A and B. The intersection of A and B is this region you can see here. It should be in in B and C, that is B union C. But don't include where A and B are intersecting. This is the region. That is the A intersect complement. Still questions? Okay. So we've done shading and simplifying. So let's just do some examples on what some of those questions I sent last time. So one of the questions was we are given that, let me just change the board because this one is